Hello, everyone. Welcome back. Today, we want to learn about the transformations of the sine and cosine graphs. So our goals, understand how these graphs can be transformed, which means shifted, stretched, compressed, reflected, both in a horizontal direction and a vertical direction, and also be able to find the amplitude, period, and phase shift of the sine or cosine graph, because those are really important aspects of sine and cosine. So first off, let's actually go to Desmos really quickly and just kind of review what the basic graphs these look like. Now, in graphing these, generally you can graph in either degrees or radians. Most of the time we're going to work in radians. So in Desmos or in graphing calculator, go to your mode. In this Desmos, you have the settings right here, this little wrench. Click on that. We're in radians. If you want to change to degrees, you just click on degrees. Right now, let's keep it in radians. And then let's graph both sine and cosine. So just do y equals and just type in sine of x. Okay. Now, if you zoom in or out, remember that these are both what are called periodic functions, meaning they have repeating parts. So they go a certain distance and they start over. And so sine, it starts here, we think it's starting anywhere. We start at 0, 0, okay? And it goes along and then it starts back here again, and then it starts over at 2 pi. So its period is 2 pi radians, or the same as 360 degrees. And this is what it looks like. And so important features are so for an angle, to think of your x-axis being an angle 0, sine is 0. You also see this, compare this to unit circle values, see they're the same. At pi over 2, sine is 1. When the angle is pi, sine of pi is 0. And then sine of 3 pi over 2 is negative 1, and then come back to sine of 2 pi, which turns out to be the same as 0, the same value, you get 0 again. So that's a graph of sine. Now, let's graph of cosine on the same axis, and we'll see how it's very similar. Okay, the blue graph. And it actually is essentially the same graph, it just shifted slightly. Okay, we'll talk about that a bit later. So let's actually turn the sine graph off. So this is also periodic with the same period. Okay, it just starts a different place. So if you think about the unit circle values, and once again, think of the x-axis as being the angle. When the angle is 0, cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Then cosine of 2 pi is 1, and we start over. And that's the period of cosine graph is the same as 2 pi. So if you go just a regular cosine or sine graph, if you go 2 pi, either left or right from where you are, you end up with the same y value. Okay, so for example, I'll pick this point right here, 0.85, and so that has an identical, if I can find it again, 0.79, and then if you do over here, you see it has the same y value somewhere right around in there. Okay, it's periodic. They both are. Now, if we compare them together, once again, they're basically the same graph, but when it's shifted compared to the other, and we'll talk about that here in a moment. So let's actually turn those off right now. Let's go back to our notes. Now, talk about today specifically are kind of the most general sine and cosine functions. Okay, are these 4 constants, a, b, c, and d. I have this both for sine and for cosine. Let's explain what they do. Actually, I should probably put this as y equals this, not just that by itself. So let me add that in. Okay. Now, what these constants do. So the first constant out in front in both cases is the a. That's the number right in front of the sine or cosine. Now, if this a, and here we're using the absolute value, if this number in absolute value is bigger than 1, the graph is stretched vertically by a. Okay, it's like taking that graph and stretching it vertically. But if it's between 0, absolute value is between 0 and 1, it's compressed vertically. We'll look at this in just a moment. Okay, and then finally, if a is negative, then the graph's reflected through the x-axis. Let's go back to Desmos and take a look at all 3 of those cases. Let's just start with sine. Okay, now let's say I put a 2 in front. What does that do? Actually, let me just do another different sine graph. So y equals 2 sine of x. Okay, so the green graph, if I have a 2 in front, see it stretches, take this graph here and stretches it vertically by a factor of 2. This point right here that was at pi over 2 and 1 is now at pi over 2 and 2. And the same thing down here, the point that was at 3 pi over 2 and negative 1 is now at 3 pi over 2 and negative 2. It's stretched vertically by 2. It's pulled away since and this is something called the amplitude here in a moment. Is how far above the x-axis it is. Okay, now, what if I put a 1/2 in front? And as we'll see, since 1/2 is less than 1, if I do a 1/2, it compresses it vertically by a factor of 2. At this point, it was at pi over 2 and 1 is not pi over 2 and 1/2. This point that was at 3 pi over 2 and 1 is now at 3 pi over 2 and negative 1/2. So it's compressed vertically by a factor of 1. Okay. Lastly, let's just get rid of this. Let's make it the same. Okay. Now, if I put a negative in front, what that does, look, watch what happens to the green graph. Okay. It basically flips it over the x-axis. Okay. So the negative just flips it over the x-axis. It's what's called a vertical reflection. Okay. And that's what the constant in front, a in front, does. Okay. Let's look at one more thing. Let's actually put a t in front. This is something neat we can do with Desmos. So I'm going to add what's called a slider. And I can see what happens if I change t. If I make t larger, it stretches it vertically more. If I make t smaller, let's get down to here is 1. If I make it smaller, closer and closer to 0, it compresses it vertically. If it's negative, and then you see it reflects it through the axis. Then if it's increasingly absolute value and both negative, then it's also reflected and then also stretched or compressed depending on the absolute value of the number. Okay, and then back to 1. And this is also something, let's go and talk about this, something called the amplitude. So the distance above of the graph above the x-axis called the amplitude. That's essentially the height of the wave above the x-axis or below the x-axis. Let's go back to our notes. Go ahead and talk about this now. So what's called the amplitude is the maximum height of the graph above the x-axis or below the x-axis is given by the absolute value of that number in front, the absolute value of a. We'll look at some examples of this later. Okay, now let's talk about our next transformation. So what this constant b does. So b, this is actually, the a gave us a horizontal or vertical, a vertical stretch or compression. The b gives us a horizontal stretch or compression, but it's kind of the opposite. What happens opposite what you think. As b gets larger, actually the graph is compressed. Okay, kind of like an accordion. So if b is, the absolute value of b is greater than 1, because b can also be negative. Let me start there. If the b is negative, it's reflected through the y-axis. We'll see that in a moment. But if the b, right in front of the x, if the absolute value is bigger than 1, the graph's actually compressed horizontally by b. Okay? But if the absolute value is between 0 and 1, it's actually then stretched. It's the opposite of what you'd expect. Let's look at that. So let's actually cancel this for now. Get rid of the t. All right, let's go back to sine. Now, let's just put a 2 in front. So see what happens is actually it's compressed. So I'm putting a 2, it's bigger than 1, absolute value, and actually it's compressed by a factor of 2. So what that means is my period, the red graph, the period we said was 2 pi, goes from 0 to 2 pi, okay, of the red graph. That's the length of the repeating part. Now this period is now compressed into 2. So it goes through that same cycle in just pi, okay? So it actually does 2 complete periods from 0 to 2 pi. So the period is actually compressed by 2 pi, or compressed by a factor of 2. And that's because the number is bigger than, absolute value is bigger than 1. It's opposite what you'd expect. So actually increasing that number compresses it. Now, then as you probably expect now, if we make this 1/2, oops, and you see you have to be careful how you do that. So let's actually put this in parentheses. Yeah, there we go. So 1 divided by 2, there we go. So here, if the number in absolute value is less than 1, it actually expands it, pulls it apart. Okay, if you want to think about an accordion, it kind of stretches it out by a factor of 2. And actually it goes, so now my period is actually double what it was before. So once again, the red graph, the period goes from 0 to 2 pi. That's a complete cycle, complete period. This one, it goes all the way to 4 pi. You see the green graph, it completes that same cycle, complete pattern, now in 4 pi. So we have half the period in 2 pi, we have half the original period. Okay, so it actually doubles the period. I'll also have to define the period a bit later. And finally, let's look at one more thing. If this is negative, put a negative here, then it reflects it through the x-axis. And actually, it's almost kind of identical in this particular graph. It's identical to reflecting it through the y-axis, but actually reflects it through the y-axis. Okay, flips it that way. All right. Now, so one more thing. Let's put a t here and add a slider. So we'll see how this happens. So once again, if I increase t, if I make it bigger than 1, I'm compressing it, okay, by that factor. All right. Then let's go back to 1. Okay. If I make it less than 1, or between 0 and 1 absolute value, then that stretches it out, makes the period longer. Okay. And finally, if I make it negative, then it flips it across the y-axis. And also the same thing happens in absolute value. If it gets bigger than 1, it compresses it. In absolute value, if it's less than 1, it stretches it out. Okay, so that's how this works. Okay, let's talk about the next factor then, about what the C does. So the C is the shift left or right. Okay, so this is kind of opposite what you expect as well. So if the C is positive, put a plus or minus here because it's either plus or minus. If the C is positive, it's actually to shift to the left, not the right. Okay, it's actually shifted by C divided by B, and we'll explain that a bit in a moment. All right. The main thing to remember here, though, if it's positive, it's shifted to the left, negative shifted to the right, and this is something called the phase shift, C divided by B. Okay, let's look at that on our graph. So let me change this. Let's get rid of the T here. Now, compare this. So what if I just shift this by, let's do a minus. Let's shift it by pi. Let's just type in pi. Okay. Now what's happened then is I took the red graph and actually shifted it. And since it's minus, it shifts it to the right. Okay. Shifted by pi. So essentially this pattern on the red graph started right here at 0, 0. Now starts this cycle that starts here at 0, 0. Okay. There. Now it's starting, essentially it's delayed. I'm starting now at pi, and it completes that same cycle for 2 pi as well. This doesn't change the period. Now it goes from pi to 3 pi, still pi over 2, but now it starts pi units later, essentially. If I put a plus, then it takes that and shifts it to the left. Okay. Might be better to do something besides pi. So let's do pi over 2. So minus pi, oops, I have a caps lock on. Let me fix that. Divided by 2. Okay. Now that's shifted to the right. Okay. But now if I make this a plus, it shifts that to the left. Okay, it's a little hard to see here. So let's do this. Let's make a T and add a slider. Now let's put it at 0. So at 0, that's just the sine of x, same as our red graph. Now, as I increase it, make it bigger than 1, it's shifting it. So once again, as this t is positive, it's actually shifting it to the left, as you can see. It's moving to the left, okay? But if it's negative, there's a negative sign right here, it's actually shifting to the right. It's opposite what you think. Also, notice it's not changing the shape, it's just simply shifting it to the right, okay? And that's something called the phase shift. And that's really important in electronics and acoustics, understanding the phase shift and how that works. Because actually, if two sine graphs like this are out of phase, what's called out of phase, like that, if you actually add those together, you get 0. So you can actually cancel out away with another if it's what's called 180 degrees or pi radians out of phase. Okay. Let's talk about the last shift, the last kind of shift, the last kind of change, and this D. So the D can also be plus or minus. So what it does is, this is one of the kind of the simplest one. If D is positive, what you'd expect, this number here is positive, it just shifts the graph up. It doesn't change the shape, just shifts it up by D. If it's negative, it simply shifts it down by D. Let's look at that. This is one of the easiest ones to understand. Let's get rid of the T again. I believe I just put the T out here. Okay, good. So now, starting at 0, if I shift it up, okay, if T increases, it's positive. It just takes the graph, shifts it up. Okay, go back to 0. If it's negative, then it simply shifts the whole thing down. It doesn't change the shape, just shifts it down. So shift either horizontally or vertically. It doesn't change the shape of the graph, just moves it either left or right or up and down. Okay, and that's the easiest one. So our goal then is to combine all these things together and see what happens. Okay, so let's review a couple more things. So we said the amplitude, we said, is given by the absolute value of A, the number in front, that tells us how far it's stretched above or below the x-axis. The period, then we actually get by a little formula. So the absolute value of 2 pi over b. So b is this number right in front of the x. And of course, b can be positive or negative. That's why we use the absolute value. The same thing with amplitude. And so what happens then is the opposite of what you think. The bigger b is, since b is in the denominator, the smaller your period is. And if b is 1, your period is simply 2 pi. Sorry, my nose is itching. Which is the regular graph. Then the phase shift is also kind of opposite what you think, and we'll explain this a bit as well. The phase shift is actually c, this number c divided by b, but if c is negative, once again, it's a shift to the right. If c is negative, your phase shift then is what's called positive. The phase shift is positive c over b if c is negative, and then it's negative c over b if c is positive. Okay, so it's the opposite of what you think, and we'll do some examples of these. Let's take a look at a few over here on the right. What I'm going to do is I want to find the amplitude the period and the phase shift, and also we'll probably graph. Okay. Also, let me mention one more thing before we get there. I want to find the amplitude, period, and phase shift. Finally, there is kind of like just like an order of operations in numbers. You're probably familiar with that. There's an order of operations in transformations. It's kind of a decision, a choice someone made, how to kind of, we're always doing this the same way. So first is a horizontal shift. That was basically given by your C, your B. Okay. Horizontal stretching compression, that was given by the number B in front. Okay. Then the next thing is a reflection about the y-axis. That's given whether it's B is negative or positive. Okay. Essentially, kind of work in the order operations, kind of like order operations with regular numbers, kind of work essentially from the inside out. Okay. Then next, what comes is if you have a vertical stretch compression, which is given by A. Okay. Then a reflection around the x-axis, which also if A is negative. And then finally, the last thing is then a vertical shift, which is given by D. So once again, order of operations, you first do your horizontal shift if there is one, which is determined by C and B. Your horizontal stretching and pressure, which is determined by B. Then if there's a reflection around the y-axis, that's also determined by B if B is negative. That's the inside. The next thing is A. If there's a vertical stretch or compression, do that next. Then if A is negative, you do a reflection about a vertical reflection through the x-axis. And then finally, the last thing is a vertical shift up or down. Okay, let's come over here then to right and look at some examples. So number 1, okay, let's say we have y is equal to 2 times the sine of x minus pi. Okay, now we still have to pick out our a, b, and c's here. So a is the number 2, number from the sine or cosine. B is the number from the x, which in this case is just 1. C is actually negative pi. Okay, it's negative, and then D is actually 0. There's no D on that 0 side. So there's no vertical shift, it's just 0. Okay, so then let's take a look at our definitions. Our amplitude, to abbreviate that, is equal to the absolute value of A, which is the absolute value of 2, which is 2. So it's stretched vertically by a factor of 2. The period is equal to the absolute value of 2 pi over B, and B is 1. This is just 2 pi, so actually there's no change then in our period. And now, finally, the phase shift okay, it says it's going to be positive. In this case, since C is negative, which it is, it's positive C over B. So positive pi over 1 is equal to pi. And once again, this since c is less than 0, since c is negative. Okay, let's take a look at that graph then. All right, let's get rid of a few of these. Let's actually just turn this off. Let's make a new graph. So this is y, and also kind of show how you do this a step at a time. So y is equal to, first off, we do the phase shift, okay, x minus pi. Let's turn on the regular graph, okay? Then we would do our, so b is 1, next do our vertical stretch, so factor of 2. In this case, that's our graph. That's how it's changed from the original one. So once again, first do the phase shift in this case, and then also the vertical stretch. And that's what the blue graph is what it looks like. Okay. Let's do a few more. Number 2. Now let's do a cosine graph. Y is equal to 1/3 times the cosine of 3x minus, or let's do plus the sign plus 2 plus 1. Okay. A little more going on this, and we'll take it all apart. So once again, let's take a look. Let's pick out our A, B, and C's. Okay. So A, once again, is the number right in front of the sine or cosine, which is 1/3. Okay. B is the number in front of the x, which is 3. C is this number also inside the parentheses. I subtracted the x term. This is going to be a positive 2, and then D is equal to 1. Now, also, D has nothing to do with amplitude, period, or phase shift. That's just simply a shift, a vertical shift. Okay. So once again, the amplitude is going to be the absolute value of A, which is the absolute value of 1/3, which is, of course, just 1/3. So what that's going to do is going to press the graph vertically by 3. The period, okay, is the absolute value of 2 pi over B, and B is 3. And so the period is going to be 2 pi over 3. So remember the original graph, original cosine, the period is 2 pi. 2 pi over 3, so I've compressed the period. I've compressed it by a factor of 3. Okay. Now, the phase shift, and this is one of the part that's kind of a bit trickier. Okay. It says, now in this case, since your C is positive, it's going to be negative C, which is 2, over B, which is 3. Okay. And I'll say since, this is since C is greater than 0. Okay. That seems a little strange, but that's actually the phase shift. It's negative since this is positive, your phase shift is negative. Okay. I'll also explain a bit why we have a C over B. Okay. Let's actually rewrite this one. Okay. We can also write it like this, see if this makes sense. So it's 1/3 times the cosine. What happens if I factor a 3 out of this? Okay, I'm going to factor a 3 out of this term. All right. I'm actually going to use a bracket, so it always be parentheses. Take out a 3. Of course, I have an x right here. And now, believe it or not, this is going to be 2/3. Okay, why is that? Well, so I take a 3 out. There's not a 3 there, so I have to divide it by 3. Okay, so this is actually the same thing. Is actually, if I multiply it back through, I get the same thing. So if I distribute this, 3 times x is 3x. 3 times 2/3. The 3's would cancel out, and I'm left with just 2. Okay, oops, I forgot my 1 out here, plus 1. Okay, so that's why it has the C over B, because actually technically think of it as factoring out the B, because remember in our order of operations, we actually do the phase shift first. That's why I think of it that way. Okay. It's easier just to remember it that if it's in this original form, you don't have to factor it out as long as you remember. You don't really have to factor that out if you don't want to, as long as you remember that it's C over B, and sign depends on whether C is negative or positive. Okay, so let's graph this one. Okay, let's get rid of this one then. So this is also a cosine graph. So let's actually let's start with the cosine graph. So y is equal to 1/3 cosine of x. You see what happens there is actually just compress it by a factor of 3. Let's actually turn the cosine off for now. Okay. Then actually need parentheses here. 3x plus 2, then plus 1. So here's the original cosine graph, and you see what's been changed. Okay. So that's what this graph would look like compared to the original cosine graph in blue. All right. Now, just to convince you this is the same thing as I said, let's do y is equal to 1/3. Now, if I factor that out like I said, I'd have 3, in parentheses, x plus 2/3 plus 1, exactly the same graph. Okay, we factored it out. And that's why I would say, so essentially what you're doing is you're first doing the shift, then first doing the horizontal shift, the horizontal compression or stretching. Okay, then, in fact, let's just take a look at that one step at a time. Let's do one more thing here. Okay, let's start with y equals cosine of x and see how this works in terms of the order of operations. So the black graph's what we're starting with. Okay, first I'm going to do this horizontal shift. So x plus 2/3. Oh crap! Let me actually get rid of both of these and just put the cosine graph up. Okay, so the blue is the original one. The black one is one I just shifted. Okay, next I would multiply that by 3. Okay, and that notice that changed, compressed it by a factor of 3. Okay, then next I would do the amplitude change, 1/3. And then the last thing, the vertical shift plus 1. Let's make sure that's the same as was before. Yeah, same graph. Okay, exactly the same thing. So that's kind of how the order of operations would work. Okay, let's take a look at one or two more. Number 3, another cosine graph. Y is equal to, now we can also use decimals here as well. Let's do like 0.6 times the cosine. And this time let's do -1/2 x plus 3/5. Okay, and this time no shift. Okay, now once again, look at the A, B, C, and D's. A is equal to 0.6. B is equal to -1/2 this time. C is equal to positive 3/5. And then D is equal to 0. Okay, so the amplitude is going to be the absolute value of 0.6, which is, of course, 0.6. My period is equal to the absolute value of 2 pi divided by -1/2. Now, this is the absolute value. Okay, and since that's -1/2, as we'll see, of course, dividing by 1/2 same as multiplying by 2/1, and see that actually stretches out the period. And also, this is negative. Okay, so it's going to mean -4 pi and just 4 pi. So that actually stretch out the period. We saw something like that before. Okay. Now what the negative does, actually, it's reflection through the x-axis. Then finally, the phase shift is equal to, and since C is positive, it's going to be positive C over B. That's going to be negative. Okay. Because we're going to put the negative because we have a negative here. All right. And so it's going to be C, which is 3/5 divided by -1/2, which is a little complicated, I know. We'll take care of that, okay? And that's going to be 3/5 dividing by a fraction, same as multiplying by the reciprocal what you're dividing by, times -2/1. and that's going to be -6/5. Okay, it's going to be negative since actually it's going to be negative since this was positive. All right. Okay, so that's our amplitude, period, and phase shift. All right, we can also graph that one then. Try and graph it on your own if you like, but you get the same sort of thing we've seen. Okay. All right, let's do one more one. Let's do one last one with a sine. So y is equal to, and this will also work the same way if you have decimals as well. And so let's say we have, as I say, we did that one decimal there. Let's do one more decimal. So I have a 0.12 times the sine of x, of x. Let's see. Instead, let's make this 0.3x minus 4.1. Okay, and then also there's no vertical shift. All right, so same thing again. A is 0.12. Make that negative. So A is negative. The absolute value of negative is 0.12, which is, of course, just 0.12. Let's talk about what this does. Since this is between 0 and 1, actually, it's compressing it vertically, okay, down to that much. All right. Once again, it's not just A. Sorry, that's the, oh, hang on a minute. I was getting ahead of myself. I was doing the amplitude, and I just want you to find A. It's okay. So negative 0.12. B is equal to 0.3. And then C is equal to negative 4.1. And then D is equal to 0. Okay, so once again, the amplitude is equal to the absolute value of A, amplitude of 0.12, which is, of course, just 0.12. And once again, that compresses it, regular amplitude, period. Okay, since this number is less than 1, between 0 and 1, it's 2 pi over that, 0.3. So it's actually going to be a larger period again than 2 pi. Absolute value of that. And let's just, this time, let's just use a calculator. So I'll just use my calculator here. So, well, actually, let's just use, since this involves a pi, you also use Desmos as a calculator. So 2, to do pi, just type pi divided by 0.3, and that's approximately 20.94. Okay, and these are radians, about 20.94 radians. So graphing radians is approximately that many radians. Okay, and then also then the phase shift. Okay, now since it's going to be C is negative, so it's going to be 4.1. It's going to be positive though, 4.1 positive over 0.3 since the C is negative. So that's kind of the opposite of what you think. I'll say since positive, since C, which is negative. Okay, so it's going to be positive shift, positive phase shift. Let's also find out what that is. Let's do that with the calculator. So 4.1 divided by 0.3, and that's going to be, also this is going to be in radians as well, so 13.67 radians. Okay, and I want to do that one example because in real life, if you have to do anything like this, there's a good chance you'll be involving decimals or something like that, not really exact numbers, but everything works exactly the same way. Of course, you can also graph it on your own. So that's how we find then the amplitude, period, and phase shift. You have understanding what those do. So once in amplitude, since it's less between 0 and 1, we're depressing it. Period, since it's smaller than 1, between 0 and 1, we're actually then taking that and actually stretching out the period. And our phase shift is to the right, since this is negative by that much. And also the negative here in front, that would be a reflection about the x-axis. Okay. So we learned so far today are basically the kind of transformations you can do with the sine and cosine graphs. Learn what each one does. We'll also learn how to find the amplitude, period, and phase shift, and also talked about the order of operations of graph transformations. Thank you. Have a good day.